All right. Example one, we'll go through two examples together, going through the whole process of conducting a significance test. So we're going to go back to the potato problem. Remember that a supplier says that potatoes have to meet a certain standard. We can have, if we think we have more than 8% of potatoes in a shipment that are bad or blemished, then we can return the shipment for another load. And then, so they just got a truckload. They select that's important, random sample. We like the word random, of 500 from the truck. An inspection reveals that 47 of those 500 have blemishes. We want to know at the alpha significance level of 0.1, do we think that more than 8% of potatoes in the sample have blemishes? Well, let's just check out really quick. What is the proportion from that sample that are blemished? That would be 47 out of 500. Oh, not 45. Oh, no. 47 out of 500, which is, I have it written down, or you can put this in your calculator. I have 47 out of 500 is 0.094. Okay, so that's a little bit 0.094. That's a little bit more than 0.08, which is 8%. But is it enough for us to have strong evidence that the whole truckload really has more than 8%? Because maybe the sample was just a little bit high, and that's what we want to find out. So we're going to go through phantoms. First, we want to define the parameter of interest. The parameter is P, because we want to know what is the true proportion of potatoes in this shipment, with blemishes. We just have the proportion from the sample with blemishes, and we're going to use that to determine if we have evidence that the whole shipment has more than 8% blemishes. H for phantoms says state your hypotheses. Well, the null hypothesis, this is going to be annoying. The null hypothesis is that the H naught, the true proportion is equal to 0.808. And the alternative hypothesis is that we want to know, is it actually greater than 0.08? Do we have strong enough evidence that this shipload or this truckload should be returned? Next, we have A. We're going to check the assumptions or conditions. First of all, it did say the first condition is random, and we were told in the problem that it is a random sample of 500. I even highlighted it above, random sample of 500. Next, we want to check to make sure that the population size is large enough, and that was, I forgot what we called that. That's the 10% condition. And so to check the 10% condition, well, we can take the sample size times 10. The sample size is 500 times 10, which is 5,000. And I think we can assume that a large truckload of potatoes has at least 5,000 potatoes. That's a pretty reasonable assumption, but we don't know that for sure. So we're just going to say we want to assume that there are 5,000 tomatoes in the, not tomatoes, potatoes. Assume that there are 5,000 potatoes in the shipment. Okay. Now we have the last condition, large counts. For large counts, we want to take N times P naught. So 500, P naught is 0.08, and that is 40. That's greater than or equal to 10. That's good. And then we'll take 500 times 1 minus 0.08, which is 460. Remember, the large counts condition says that those both have to be at least 10. And I have met all three conditions. The one I had to assume, but I think it's a reasonable assumption that there are 5,000 potatoes in a large shipment. N, name the test. This is a one sample z-test for the population proportion, P, z-test for P. T, the test statistic. All right, so now we're going to use the calculator. We can write the formula that we learned in the last class, but let's actually just skip that. Let's go straight to the calculator. I'm going to open up a new document. We're going to go to a calculator page, menu, statistics, stat tests, and a one proportion z-test, number 5. P naught is 0.08. That's our hypothesized proportion. How many successes? Well, it said that we had, what was it? How many bad potatoes? I think it was 47 out of 500. Should I check and see? Just want to make sure. Is it? Yes, it was 47 out of 500. And our alternative is our proportion greater than P naught? So we had a greater than symbol with our alternative hypothesis. And our test statistic is Z, which is 1.15. So we can write Z equals 1.15. And if I want to draw a curve, which I highly recommend, and I'd like to see on your practice problems, what you can do is put 0 in the middle. 1.15 is how many standard deviations away the population proportion is. And then this area here is the p-value. And it told us that, and that is O is obtain the p-value. And it is the proportion of the curve that is shaded there, which, back to the calculator, there we go. P-value 0.124. So we have 0.124, and that is that area there. Is P low? It's not very low. Why is it not very low? Because P, the p-value, is 0.124, which is greater than the alpha, 0.10. Our alpha for this problem, it told us at the beginning, was 0.10, which is equal to the alpha. So since P is low, we failed to reject the null hypothesis. Failed to reject H naught. And we can state our conclusion. We do not have convincing evidence. We do not have, remember, if you fail to reject H naught, that means that we do not have convincing evidence that the alternative is true. But we want to write this in context. So the alternative was that the true proportion of blemished potatoes in the shipment, that the true proportion of blemished potatoes in the shipment is more than 0.08. We did not find evidence for that.